All right, so let's do one that has a interesting shape. So we'll do this. All right, and blow that up just a bit. We're going to call this 4 inches. We're going to call this 5 inches. This is going to be an inch, and definitely not to scale, but we're going to make this one 2 inches. And I need to squeeze some arrows in here. Okay, what did we miss? Oh, we got to dimension this one, so this will be an inch. All right, now that's all we need. Okay, and the promise statement is kind of like this. So, locate centroid of Okay, so we're going to keep this in somewhat less confusing if we do this with a table. But we're going to be looking for, and I'm going to do this with an exaggeration here. We're going to call this like so. Okay, and I want to do it with a little flare on the X, and we're going to put a bar over top of it. Okay, and then we're looking for Y, and we're going to put a bar over top of it. All right, and those are going to be two centroids we're looking for. So both the X and the Y have pieces to this. Sometimes they're only going to ask for one. This particular problem, we're going to look for both. Okay, so the first thing to do with this is identify this as object 1 and this as object 2. Okay, and actually I want to get that 2 out of there. I'm going to put it over here because I am interested in where the centroid is going to be for that. Okay, so to make this easy, we're going to do a few things. We're going to look for, you can go away, don't need you, go away. We're going to look for the area, okay, and the units on that are inches squared. Then we're going to look for X bar, and that's going to be in inches. Then we're going to look for Y bar, and that's going to be in inches. And then we're going to look for X bar A, and that'll be inches cubed. Okay, then we're going to look for Y bar times A, and that'll be in inches cubed also. Okay, and don't panic, we're going to get rid of a lot of values here, but we're going to then label object 1 and then 2. So what are we looking for? And then we're going to sum certain parts of this table up to do things, okay? So if I look at area 1, we are 1 inches wide and we are 8 inches high. So my area for that is 1 inch times 8 inches, and that'll be 8 inches squared, okay? I don't need the units in here, so ideally we would just table this as an 8, okay? So I'm going to put that right there. All right, now area 2 is 4 inches, but we lose the inch for this one and just deal with this section right here, okay? And that's going to be 3 inches this way times an inch. So that makes our area for that one 3. Okay, so in the first one, the centroid of X is going to be right down this middle here. So let's draw, we're going to have our center line like so. Okay, and that'll be half of that distance. So our X bar in this case is 0.5, okay? And in our object 2, we are going to be 3 inches. We got to come from some known place, okay? So I did this first one. We actually came from, let's do this. We came from here and here. This was 0, 0. Okay, so half of 3 is 1.5. All right, and we come from this side over. We're going to add an inch, so that this is 2.5. Okay, so always establishing some edge or place as a baseline. Okay. We could have called this in here, this line, 0 for X, and that would have made these negative that way and positive this way. Start in the lower left-hand corner if you can, then everything is positive, positive, and it makes life a little bit easier. Okay, the Y. So for 1, Y is going to be halfway up here, so we're going to get a centroid like so, and that'll be 4 inches from there to here. So our Y centroid is 4. Okay, and on 3, again, we're coming from this base down here. We're 1 inch or 2 inches up, and then half an inch there. So this value is 2.5. Okay. And now what we're going to do is take the area, multiply it times the centroids, and get these numbers. So this one is 4. So this times that leads to that. Okay. And then the Y bar times the area is 8 times 4, which is 32. And then this one turns out to be 7.5 and 7.5. Okay. Now, here's where this becomes the summations. We're interested in that one, and that one, and that one. Okay. So 8 plus 3 is 11. That's inches squared. This one is 4 plus 7.5. So this is 11.5 inches cubed. And then 32 and 7 makes this one 39.5 inches cubed. Okay. Now, if I want to find out where this thing exists for the centroid of the whole bit, we're going to be really interested in this. Okay. I'm going to use my centroid x for the master, okay, for the total figure. All right, and it's going to be the summation of the areas equal to x bar times a. So I'm going to put a parenthesis around that because we are actually pulling this one from here down to there, okay, or the 11.5, right? And that leaves me with or 11.5 divided by 11, and that's going to give me a 1.045 inches, okay? All right, and then do the same thing for y. Actually, make a better y than that. Times the summation of a equal to y bar a, and we're going to get the same thing, y equals y bar a parentheses divided by the summation of a, and that will be 39.5. Oh, I should put some units on this, make things a little clearer. Inches cubed divided by 11 inches squared, and that will leave me with 3.59 inches. All right, let's doctor up this other one up here. So this is inches squared, inches cubed, okay? And those are our answers. Now let's take that and put it back in perspective here, okay? So I need a different color here. Let's use blue. So I'm 1.045 in this direction. 1.045 inches in that direction from the baseline of 0, okay? And that'll put it someplace kind of out here, okay? And then from the 0 going up, I am 3.59. So that's 2 inches, 3 inches, 0.59 more up above this. And we're going to call it right there, okay? And go that way, 3.59, and that right there is our centroid. So everything comes around that. So you can do this with any problem, just have to do the following steps to it, okay? First, break things into their natural geometric shapes. Could have done this as a long rectangle here with a rectangle up there and then a small square down here, or actually this would have been a rectangle too because it's 2 by 1. That would have been 3 components to this, which is fine. Some shapes actually lend themselves to looking better for you than others. Okay. All right. How about a fun one that you can try, and I'll give you the answers, and then you can actually see what you can come up with. Okay. All right. So here's a practice problem for you to do. Okay. We are going to start with this. We are going to be 3 and 3. Okay. So we're going to do this. Yeah, that's pretty much what I want. All right, now let me give you some axes here. So we're going to call that Y, call that X. Okay, now here's the fun of this. So this curve here is 60 millimeters, and that's a radius of, well, I'm going to call this one 2. I'll call this one 1, and then I'm going to show you a third one here in a minute, but this will be radius 2, okay? And then from here to there, we're going to get radius 3 will also be 60 millimeters, okay? And let's see, here's how I'd go about doing this particular problem, okay? So start with this, create yourself a rectangle and draw it up and like so, and that is 1. And then 2 is a full semicircle. This will be 2. Okay, so the couple things you need to go look up, and this is in your book, the area of a circle and then remember to divide it by 4. Okay, so pi r squared and divide it by 4, and that'll give you the area of 2. Okay, now the other piece is we're going to take all that and we're going to subtract it from this curve right here. Okay, and this will be 3, which is everything related to radius 3. Okay, and again, it's the same equation. Area 3 is equal to pi r squared over 4, and you're going to get that. And then 1 is a rectangle. Okay, and just to make sure everybody's on track, so if we have a radius of any shape, it is the radius of 3 is the distance here. Okay, so remember some geometry. Okay, so let me give you the answers. You create the tables, and if you get it right, you will know you solved it correctly. Okay, and these are your answers. All right. Have fun with that one. See you in the next video.